we are going to be looking at section 4.5, solving rational equations, fractional equations, right? And we actually did a lot of this in chapter 1 when we were solving equations in general, and some of them were fractional equations. So let's take one and just see what we have here. So this is on page 56, and it's problem C. And here's the equation we'd like to solve. K minus 4. Let's see what's coming with this problem. I hope you see that. Ooh. Very complicated problem. Okay. All right, there's an example of it. And before I do it, I'm going to give you a chance to try it on your own. So if you could possibly, reach back into your memory when we were doing chapter 1. Let's see if you can solve this problem. The object here is similar to what we've been focusing on since we've been doing rational expressions. The purpose here will be to get rid of the denominators. And once again, we look for the least common multiple. But I'm going to rewrite the equation. With equations especially, I like to rewrite the problem. I should be doing that with every problem, really, because it's always good to have the original. But so this is the equation, and the least common multiple, in other words, that number which everything divides into evenly, is going to be 21. And we multiply each term by 21, including that term over there. This is probably the biggest mistake of any part of solving this problem, and that is students who forget to multiply the 1 by the 21. So put a star next to that. Now let's see what we could do here. So 7 into 7 is 1. That's good. 7 into 21 is 3. And this becomes 3 times 2 is 6. Minus. Now be careful here. 3 into 21 is 7. And that's where the 7 goes. And don't forget there's a minus sign over here. So I could see, problems over here. I could see what could happen there. Both of those drop out. We get minus k equals 21. Now I'm just going to check myself, make sure I have that right. 7, 3 is 7, 7 times this, okay. All right, so we have 6 minus 7k plus 28 minus k equals 21. Now let's combine like terms. So we're going to combine these two like terms, and this will give us negative 8k. Then we're going to combine this, and that'll give us plus 34 equals 21. Doesn't even come out to a whole number. 34. Negative 8k equals negative 13. And k is equal to 13 over 8. If you'd like, you could change it. And this is the answer that I got. I don't know, is it right? I was very unenthusiastic about this problem when I realized but it wasn't going to come out to a whole number. But you know, this is the fraction. This is the fraction chapter, so that's going to happen. Okay. Does anybody, you know, concur with this? Anybody get the same answer? I know people probably did this and got the right answer.
I got the same answer, Professor.
Good. Thank you, Max. Good. Good. Very good. Okay, great. Okay, so let's go on to problems that will be much more important for us to focus on. And we'll go down to problem G. What we're really going to be focusing on in this chat, this was just to kind of warm everybody up, but this next problem is a problem in which we're going to really, this introduces the new stuff in the chapter. The stuff we did in chapter 1 was similar to this, but this is different because we never had, I don't think, a variable in the denominator. And this is a different type of problem. But the way we go about solving it is almost exactly the same as what we've been doing all along. We're still attempting to get rid of the denominators. And therefore, we do look for the least common multiple, which will be x minus 2, x minus 2, and x minus 2. Is it clear? Before I go any further, you know, because I know that students tend to, you know, go back to stuff because they're copying and whatever. So any problems here so far? This is pretty clear what I'm doing. And now you get rid of the denominators and you wind up with 3x plus 1 plus, well, the denominator here is 1, but you know, there's nothing to cancel out. So this just will be 2 times x minus 2. This cancels out with this equals 9. Okay, so that's what, let me just check my work. Best way to check is to just start out by checking your work. Okay, that looks pretty good. And then 3x plus 1 plus 2x minus 4 equals 9. And then 5x minus 3 equals 9. Okay, I got the -3 from the +1 and the -4. Once again, we get a fraction. I'm just disappointed because it kind of robs us of the opportunity of checking. Because trying to check an equation with a fractional answer is extremely difficult. You know, you'd have to let x equal, you know, that, and it's just way too complicated. You know, to go back and let x equal 12/5, that's just way too complicated. But this is typical of the way you would solve an equation that has a variable in the denominator. Okay. Now we're ready to tackle some more difficult type problems. So let's go on now to page 57. And let me go back up here and see if I can fit this in. Page 57, problem M. I'm going to let you try it. First problem with, you know, it's a little more complicated. I'm going to let you go and try it on your own. So everybody, right now, you're doing this problem. I'm not going to do it. I would just like to begin. And if you're still working, continue working. But for those of you who do not know what to do, and I would imagine that, so all I did is rewrite the equation. Now I can see that this requires factoring. So I have y over y plus 3 plus 2 over y times y plus 3 equals 6 over y. Okay, so this is the very important step here. Going from here to here is the key step. Okay, and now I'm looking for the least common multiple. I'm rewriting the problem. Keep rewriting the problem because it's always a good idea to retain stuff and also to give yourself more room. Okay. So the least common multiple must have a y plus 3, because this has a y plus 3 and this. This has a y and that has a y. So we're going to multiply everything by y times y plus 3. Y times y plus 3. And y times y plus 3. So we're basically keeping to the same theme of always multiplying by the least common multiple. Now let's see what we get out of this. So we cancel out the y plus 3's, multiply y times y, and get y squared. This is good, right? The y cancels out, the y plus 3 cancels out, and we get the 2. Equals. Y cancels out, we get 6 times y plus 3. And now you could see the issue here is right over here. Because now we're going to have to come to grips with the fact that we're going to have, as a result of all this, a quadratic equation. So this becomes the real issue. But let's continue. Y squared plus 2 equals 6y plus 18. So we have y squared plus 2, and I'm allowing room over here like this because I want to now bring over the 6y, bring over the 18 to over here. Well, let me move this over. Now I could sort of move this over to here. Move the 18 over to here. And this is what we get. We get y squared minus 6y minus 16 equals 0. There it is. There's your quadratic equation. Okay, well, that's, no big deal. And it's always going to be a factorable thing, right? It's always going to be a factorable trinomial or whatever. So don't worry about that. And that's a hint. It's a hint that it's always going to wind up with a quadratic equation, which can be factored. And you can see that the factors are 8 and 2. 8 times 2 is 16. The negative 8 and the positive 2. Set each factor equal to 0. Just as we would normally solve a quadratic equation. And this becomes y equals negative 2. This becomes y equals 8. I'm just going through this in my mind. It's very positive that this, this can be factored into that. When I saw this, I said, I'm definitely doing this right. And then, I got these answers. I'm a little disappointed in these answers because what I was doing was then I was going back and checking. When you solve a problem which winds up having a quadratic equation, in other words, two roots, then there's a possibility for extraneous solutions, and therefore you need to check. But I don't see that happening, because if you substitute the -2 in here, I don't think you're going to have any, you're going to have negative numbers in the denominator. That's okay. The problem is when you have a 0 in the denominator. But having a negative number, that's fine. This looks pretty good, so we don't have to worry. Any questions about this problem? Let me bring it where you could see practically the whole problem. Okay, so that went pretty smoothly. Okay, and now I'd like to go to another problem. And I'm going to erase this, so give me a moment. Back up to the top, and let's take a look at a problem like this. So let's see what I got here. Okay, this is a problem on page 57, and it's problem F. And here it is. I'm going to ask you to solve this problem. Okay, so that's what we're doing right now. I'm going to give you some time, and let's see if you could solve it. I think you should be able to. I think you know enough right now about this particular topic to be able to do this. Here's where I'm picking up the problem, right over here. So I rewrote it, but in the process of rewriting it, I decided to factor that denominator because, you know, what the heck? You know, as long as we're rewriting everything, this became this. That's pretty obvious. Now we want to multiply by the least common multiple, which will obviously be a combination of y minus 3 times y plus 3. Over here, y minus 3, y plus 3, and over here, y minus 3, y plus 3. Okay, so there we are. So this drops out with that. The two y plus 3's drop out, and we wind up with 2y minus 2 times y minus 3. Minus, since both of these are going to drop out, equals 18. Equals, this drops out, y minus 6, y plus 3. Okay, so let me just make sure I have that the way I'd like it to be. Okay, now we have some multiplying to do, some rearranging of terms. So let's do that next. So let's multiply here. 2y squared and negative 2y, negative 6y. This looks like negative 8y. So that's 2 and 6 is 8, both negatives, and then positive 6. Negative 18 equals y squared minus 3y negative 18. Ah, very interesting, huh? Wow, that looks very, very suspicious. That worked out too nicely. Too nicely. But look at this. This drops out with that. Beautiful, right? And then what else do we have? Well, let's bring over, well, let's rewrite it. 2y squared minus 8y plus 6 equals y squared minus 3y. That's where we are. That's where we are now. So next, we're going to bring over the y squared, and that'll give us y squared. Let's bring over this over here, negative 5y, positive 6 equals 0. Again, I'm just stopping to check my work, make sure that's just the way I want it. Okay, good. Now let's factor this. remember, it will always be able to be factored. And that's a 6, that's a 1. Nope, that's not gonna work. Okay, so that's not gonna work. But 3 and 2 will work, fortunately. So that's negative and negative. The -2, -3 is +6. The -2, -3 added is -5. Y is equal to 2, and y is equal to 3. Now, this problem was assigned to you first, of course, to solve a typical type of equation that you're going to need to be able to do on the next test for sure. The equation will definitely look like something like this. But, and also because we need to check these solutions. Okay, we need to check the solutions. And I could immediately see that we're going to have some problems. So here's the check. And we get, rewrite the rewrite the original equation. Okay, that's that. And that's that. And I don't know if you could see this yet, but if we substitute the y equals 3 in this equation, what will and you could forget about the numerator. It's not the numerator we're concerned about. We're concerned that the denominators are not going to be 0. That's the important thing. Okay, so let's just focus on that. Let's not even focus on the numerators. So take the y equals 3 and substitute it here. It looks good. 3 plus 3 is 6, not a problem. But over here, we have a problem, because that's going to be 3 squared minus 9. 3 squared is 9. 9 minus 9 is 0. Uh-oh, right? And then here, again, 3 minus 3 is equal to 0. So this is no good. If we substitute the 3 into this original equation, we're going to get 2 of the fractions with 0 denominators. Therefore, y equals 3 is not a solution. No good. Is that clear? So this is what we have to come to grips with now that we didn't have to come to grips with in the previous problems we did relating to this. And that is, what do the denominators look like when we substitute the solutions? Here, we're going to get a 0 denominator. Here, we're going to get a 0 denominator, because 3 squared is 9. 9 minus 9 is 0. This is okay, but it doesn't matter. All you need is one fraction in this equation that has a 0 denominator. So that's not a solution. But this is, because there's nothing we can do here. 2 plus 3 is 5. That's great. 2 squared, this is going to give you a negative denominator. That's okay. This will give you a negative denominator. That's okay. So the answer is y is equal to 2. And that's the only solution that we have.
Just a real quick question. It's kind of small, but just to be reassured, if you can tilt up a little bit, thank you. So you see in the part where it's sorry, you keep the minus 18 instead of like putting it together with the 6, because they're like, and that will give you
Oh,
-12.
yeah,
I did that way too, and I ended up with like y squared minus 5y equals -6, which would then mean you move -6 into y squared minus 5y positive plus 6, right?
okay,
So it's the same answer.
okay. Let's take a look at that. Let's take a look at that. Because you know, I sort of pulled a fast one. Okay, I understand that what I did here, I thought everybody would get that, but I could understand why you would combine these and get -12. So let's look at that closely. But I need to erase this in order for me to have enough room to focus on that particular issue. So let me do that before I continue. So is there any question about what happens below this, especially with the extraneous solution? Okay. I did want to give you another one so we could do another one of these because this is kind of an important thing, but that's a good question. And I want to go over it and see what happened here. So this is what the question, what Emily's asking this question, right?
Yeah, sorry.
Okay. No, I beg your pardon? Did you say I'm sorry? Don't say I'm sorry, please.
Oh,
It
okay.
is your number one, it's your class. You can ask any question you want. And number two, don't be sorry about it. That's great that you're asking a question. I think that's wonderful. You know how I am with this stuff. Okay. So I assume that what you did was this, right? Did you do this? Yes?
Yeah, I was just like wondering because
Wait a
sometimes,
minute.
yeah,
So you got this, right?
yeah.
Okay. Now, what did you do next?
Um, the I subtracted, let me see, the -12 with, and I canceled the -12 and moved it to the other side, and then I got like,
Okay, wait a minute.
mhm.
You want to do this first. Okay, I wouldn't have done that, but okay, that's that. You got that, right? And you're left with this. Yes?
Yeah, and then I did what you did with the y squared minus 3y, and then it left me with,
Wait. So you did this next, right? You did this next, right? And you got y squared minus 5y. And then what'd you do with the -6?
I just like moved it over, and that was gonna give me y squared minus 5y equals 0. Yeah. So I was wondering if that's also an okay thing. Like,
Yes, sure, because you wound up with the same exact equation
oh,
that
okay.
I wound up with.
I just wanted to make sure it wasn't like, yeah.
No,
Okay,
no, that's you could do that if you wanted to. If you saw that, that's fine. You get the same answers. Same answers. And if you saw this, but didn't, do that, that's fine. So the answer is yes, that's perfect.
thank you.
You're welcome. Thank you for asking. One last problem. Can you hang in there? Can you do this? One last problem. We still have theoretically 25 minutes, I gave you a pretty long break in the middle, so I'm reclaiming my time and I'm giving you one last problem because I like this problem and I don't know where it's gonna go, honestly, but I'd like to give it anyway. And here it is. So it's on the same page, 57, and it's problem T. Wow, they sure had a lot of problems in this section, I'll tell you that. 1 over x minus 2, finally we're back to x, plus 9 over x plus 2 squared equals, this looks very interesting. I can't wait to do this. See, this is why mathematicians are so crazy. I'll give you a few minutes because it's now 4:13 good. So I'll give you like 10 minutes to try it and then we'll do it together. This is what I have right here. And, you know, you could leave it like this, but I would suggest putting it like that because it's easier to read when it looks like that. So the least common multiple is, let me rewrite that. So we have that original equation. I like keeping things the way they look. Okay, now the least common multiple will be x plus 2, x minus 2. X plus 2, x minus 2. And x plus 2, x minus 2. So remember that all we want to do is multiply by something which will get rid of the denominator. So even though there's two of them here, oh, wait a minute. Very interesting, right? Since there's, so we can cancel that out with that, but that'll remain. So this is wrong. I think we need another one there. And therefore, I think we need another x plus 2. This is why this problem is crazy. Oh my God. This is, this is fine. That's fine. Okay. So in other words, what happens here is this drops out with this drops out with this, and you're left with x plus 2 times x plus 2. That's why the numerators are all numbers as opposed to algebraic expressions, because then it would be, you know, x to the third power. So we get rid of that with that. We need two of them because you can't get rid of both of them with only one in the numerator here. So we get rid of both of those. We have that plus 9. Now get rid of the pluses. And there was still an extra -2 here, right? So, okay, so times 9 minus times x plus minus 2x minus 2 equals, this drops out. Oh, but there's two more. Oh my goodness. Oh, now I can see why this was the last problem in the chapter. Okay, that's what we have apparently. I wouldn't, you know, do I have that right? I'm kind of moving a little too rapidly for my own comfort. I'm moving too rapidly for my own comfort. So I just want to make sure I have that right. Oh, I forgot the 6. Good thing I stopped. Okay, so here you get x squared plus 4x plus 4. Here you get 9 times x squared minus 4x plus 4. Here you get 6 times x squared minus 4. X squared plus 4x. Now, you know, what I said earlier was that these are always factorable. I got to see this to believe it. All right, I'm combining some like terms here, obviously. X squared and x squared is 10x squared. Get rid of it. Then 4x minus 36x is negative 32x. Then 3 and 36 is 39 equals 6x squared minus 24. Am I doing this right? Is anybody checking me? Allison Lee, are you still in the class? Oh, I see a mistake. 4 plus 6 is 40. Here's a mistake. Whoa, good. Good for me. This plus this is 40. See, one little mistake and you're really sunk. And positive 24, positive 24. I'd be shocked if this worked out, really. And I'm not going to feel too badly about it. That goes out with that. Minus 32 plus 64 equals 0. Okay, see that? Now I'm going to factor out a 4. This is an x. 8x plus 16 equals 0. All right, so 4 times that, 4 times that, 4 times that. Okay. Get rid of the 4. Divide by 4, get rid of it. That's out. X squared minus 8x plus 16 equals, it can be factored. How do you like that? I must have done this correctly. 4 and 4, negative and negative. The answer is x equals 4. Which is no good. Because the original equation, okay, so everything comes down to x equals 4. Okay, so that works out nicely. But when we put this x equals 4 back into here, it's not going to work out. Oh no, it is going to work out. Excuse me. Oh, it's going to work. Yeah. Good. Okay, that's the answer. It works. The answer is x equals 4. If the answer were x equals 2, we'd have big problems. But x equals 4 works, and that's the end of the problem.
Sorry, I just wanted to ask a question. I think I missed like the first part where you were, why did you put x plus 2 instead of x minus 2 and x plus 2? And for 9 as well, I got like 9x plus 2 and then x minus 2. Oops, I can't see, sorry.
I mean, what do you mean? I don't understand.
Oh, no, below actually, like the first line like down, like where it starts with x plus 2. No, like the other one. No, below, sorry. Yeah, that whole row.
Because the x plus 2's, because I was just multiplying by one of them. Originally I was multiplying by x plus 2, x minus 2. But then I realized that in order to get rid of both of these, I needed 2 of them.
Okay, yeah,
That's
sorry.
why I put this.
Yeah, all right. I followed the last part. I needed to remember the beginning part.
Okay.
Thank you.
All right. Anybody else? Very, very complicated problem with a very, very nice solution, actually. I mean, to do all this, look at all this. This is really, a really complicated problem. But we wound up with an answer which actually works. So that's